Hi everyone, my name is Yashwini.
I'm Sariswari.
I'm Akmal Majid Shami, and good morning for everyone. We are Group 9, and today we are excited to present our final project for Programming Technique 2. Project specification. Now I will explain the project details for our games. The Ninja Return. Game title. Our game is called The Ninja Return. Is about Ninja who comes back from to save his village. Game idea, it's scoring shooter game. The player controls the ninja, moves up and down and throws the enemies. The goal is survival all enemies waves and protect the village. We got ideas from two games, the zombies and space shooters. The game story, the main characters is ninja named Kishiro. He comes back, fight dangerous snakes that attacks his village. The player moves the ninja with W and S keys. The ninja throws automatically. There are three waves, pose, fighters, and upgrade options. Win and lose. Uh, you win if you finish three waves and stop all enemies. Uh, the implementation of game. We developed the game using C++ and the H library. Our code is structured into three main files: game H for user interface and screen creation, game CBB for the visual and transition, and main file that control the gameplay, include movement, shooting, wave, logic, and all gameplay introduction, like firing bullet and handling enemy behavior, or counter through three factors, and logic loops. Okay.
Next, moving on to encapsulation. So basically the definition is encapsulation is one of the core principles of OOP, and it refers to the practice of bundling attributes and methods within a class while restricting direct access to some components to protect the internal state of the object. So in our game, The Ninja's Return, encapsulation is partially implemented through the game class. This class contains methods that manage the visual transitions of the game. These methods are encapsulated inside the game class and be called from the main function without revealing or modifying their internal workings. For instance, the logic for loading the intro screen and menu visuals is completely hidden inside the game class and accessed through method calls. However, player and enemy attributes such as health, poison, and bullet tracking are currently managed in the main function using variables and vectors such as enemy health, bullet X, bullet Y, and is bullet fired. While these are not encapsulated within a player or enemy class yet, the current structure stimulates encapsulation by organizing and controlling game logic flow through functionally grouped code sections. Encapsulation could be further improved by creating separate classes such as player, enemy, and bullet, each with their own methods and attributes like move, take damage, or shoot. This would allow better control over each game element and reduce dependency on procedural logic in main. By encapsulating logic in such a way, changes to how a game component behaves can done independently, improving code maintainability and scalability. Next, association. Association in OOP refers to the relationship between two or more classes where one class uses or interacts with objects of another class. In our game, association is shown in how the main function interacts with the game class and controls different parts of the game. For instance, an instance of the game class named starts is created in main function. This object is then used to call the loading game, game menu, show congratulations screen, and game over methods. This is a one-way association where main function uses the services of the game class to manage user interface elements, but game does not hold a reference to main. Another form of association is seen through the use of vectors like bullet X, bullet Y, and is bullet fired, which are used together to track the position and state of multiple bullets fired by the player. Although not implemented as separate classes, the logic associates bullets the player by linking their creation and updates to keyboards, actions, and coordinates tied to the ninja's image position. Additionally, the enemy's position and health values such as X enemy, Y enemy, and enemy health interact with bullet coordinates during collision detection, associating them during gameplay through the code logic. This interaction simulates association by having different game elements like bullets, enemies, and player cooperate to control gameplay dynamics. In short, association allows different code modules and data structures to work together while keeping their definitions separate. Introducing full classes in the future would formalize these associations and make the code more cleaner. Next, we are going to go through aggregation. Aggregation is a special form of association where one class contains a collection of objects from another class, but those objects can still exist independently. So, to say it in another words, the lifetime of the contained objects does not fully depend on the container class. In the Ninja's Return, aggregation is demonstrated through the use of vectors to manage game objects like bullets and simulated enemies. The main function maintains vectors like bullet X, bullet Y, and is bullet fired to represent bullets that are fired by the ninja. These bullets are objects stored, moved, and rendered and deleted as needed independently of any class structure. The bullets can exist as long as they are needed and are removed from the vector when they go off screen or hit an enemy. Similarly, enemy attributes like enemy health, X enemy, and Y enemy are treated as independent game elements and managed during each wave. When a wave ends or the enemy is defeated, these elements are reset or updated without affecting the rest of the game. Although aggregation is not implemented through class structures such as game containing a list of enemy objects, the concept is simulated through how these entities are grouped and controlled within loops and conditionals. The lifetime of each game element, like bullets and enemies, is independent of others and managed collectively by game logic. So, if object-oriented design were applied, the game class could aggregate multiple enemy or bullet objects through vectors or list of object pointers, making the system even more organized.
Okay, so now I'll be talking about composition. So, composition is basically a strong relationship in object-oriented programming where one class owns another, meaning that the contained object cannot exist without the parent. So, if the owners were destroyed, the components will get destroyed too. In our game, The Ninja Returns, you can see that the composition is how the game class manages all the visual screens. Functions like loading game, game menu, show congratulations screen, and game over are tightly packed within the game class. They don't make sense outside of it. So if the game's object stops running, the screen should stop too because it fully depends on it. So another indirect example is how we manage gameplay data like wave counter, enemy health, and ninja lives. So the variables sit in the main function instead of being inside a class, but they are fully tied to the game loop. Once the game ends, the data will reset or disappear entirely. If we wanted to make the game more advanced later on, like by creating actual player and enemy classes, then the things like weapons, states, and animations would definitely follow the composition too, since their existence would depend on the parent object. So even though we don't have nested objects yet, the way the game is built shows the principle of composition through how tightly gameplay elements are coupled with core game flow. Next, next for inheritance, this is where a class can inherit properties and behavior from another class. It's super useful for cutting down repetitive code and making future upgrades easier. In the Ninja's Return, we don't have inheritance yet, but we are planning for a couple future ones. So for example, if we create a base class called character with shared stuff like X, Y, health, and move and take damage, then from character we can create two subclasses. One will be player for the ninja and another one will be enemies for the snakes. Yes, and the player class could add functions like shoot and update score, while the enemy could get methods like to attack the player or respawn. This way, both classes get all the basics from the character, but still have their own unique features on top of it. And for polymorphism, which is basically, it lets us treat different derived classes as if they're the same base class, but they still behave according to their own rules. A good example would be if we create different enemy types, like fat snake, strong snake, or like a boss battle snake, and all of them would inherit the enemy, which itself inherits from the character. So let's say we have a vector enemy pointer. Then when we loop through the vector and call something like move or take damage, each snake type will still run their own unique versions of the method, even though we are calling from the base class pointer. So that would make expanding the game easier. And if we were to add new enemy types later on, we won't need to rewrite the collision or movement code. So that's how polymorphism would handle it automatically. Lastly, for array of objects, this is when we store multiple instances of a class, usually in an array or vector. It's really handy in games when you want to manage multiple things like enemies, bullets, and obstacles at the same time. So in our game, we don't exactly have an array of class objects yet, but we're stimulating that using vectors. For example, we have bullet X, bullet Y, and its bullet fired, all vectors that track the bullet position and states. Every frame, the game loop updates these vectors to move bullets, check collisions, or remove bullets that go off screen. It's similar with enemies, where we use variables like X enemy, Y enemy, and enemy health to control them. So even though we are not yet storing enemies as full objects inside a vector, the logic still handles them dynamically each wave. So in short, even though we are working with basic variables and vectors, the way we are reusing them already shows the idea behind arrays of objects. Okay.
Now I will explain our UML class diagram. This diagram shows how the different parts of our game are connected. We have main class called character. It has basic things like health and position. The player and enemy both come from this character class. That means they share the same things like health, but also have their own features. For example, the player can shoot and the enemy can move. The player has weapon. This called competition. It means if the player is gun, the weapon is also gun. The game class control everything. It works with the player, enemy, weapon, and the game screen. This is called association, but they work together. The game also manage a group of enemies. This is called aggression. It means the enemies are part of the game, but they can still work alone. So this is this UML diagram help us to plan our code and keep everything neat and organized. And for calculation,
Okay, so in conclusion, our group has successfully developed the concept and structure of a 2D side-scrolling shooter game titled The Ninja's Return. So our game basically offers players a fast-paced experience that challenges their timing reflexes and precision while introducing simple controls, upgrade mechanics, and wave-based enemy progression. So this project not only strengthened our understanding of OOP theory, but also gave us a practical experience in applying this concept to a real world game development. We gained valuable insight into game planning, structural design, and the importance of clear class relationships and coding organization before the actual programming phase begins. Overall, the Ninja's Return serves a strong foundation for further development in future stages where we can continue refining gameplay mechanics, adding new features, and enhancing the player experience. That's it from our group. Thank you.
So here is the recording of our gameplay. So this is the loading screen, and when the mouse goes on start, it will glow. So it just starts off with the snake and the ninja. You can press up and down and the space button to attack the snake. And this is round 2. So she lost that one, so you have to go again. The ninja has 3 lives. Okay, so now the third one. Each round, the life of the snake will increase, and so will our bullets. And that's your victory. So now we're gonna run again to show what game over would be like. Okay, so she lost one time. Okay, she won the first round, but she also lost one time. So now she's on 2 lives. She lost her second life, and now this should be her last chance. And so yeah, that's game over.